f of x equals the quantity x plus 1 cubed plus 8. When we look at the domain, we're trying to figure out, is there any restrictions upon the x values that can come into our function? We're looking for things like even roots. We're looking for denominators. In that case, we don't have any. And so for this particular function, there aren't any restrictions on the x values or on the domain. So it's going to be negative infinity to infinity. For the range, we're interested in which y values, or what is the result, my output right here. And we could try that with a very large number and a very, very small number to go in there, but we find that our range is also negative infinity to infinity. As far as our x-intercepts, usually we let our y equal 0, but in this case it's the entire f of x. So we want to go 0 equals the quantity x plus 1 cubed plus 8. And we want to find out which x value gives us that state. So I'll first subtract 8 from both sides. So negative 8 equals the quantity x plus 1 cubed. Now to get rid of the cube, I will cube root both sides. And the cube root of negative 8 would be negative 2. So negative 2 equals x plus 1. And lastly, subtract 1 from both sides. So negative 3 equals x. I can write that as a coordinate then, negative 3, 0. For my y-intercept, we want to let x equal 0. Or, to think about it in terms of a function, what is f of 0? In this case, it would be 0, the quantity of 0 plus 1 cubed, plus 8. And I can simplify this to 1 cubed plus 8. 1 cubed is 1, so that is 9. So I have the y-intercept at 0, 9. Now that I've evaluated that, let's come to graphing it, and we can make a table. I've chosen negative 3, negative 2, negative 1, 0, 1, and 2. And as we put those into our function, we can see what will come out. If I put negative 3 in there, I'll get negative 3 plus 1 cubed plus 8. And that's going to equal 0. So I have the coordinate negative 3, 0. If I put negative 2 into my function, negative 2 plus 1, quantity cubed, plus 8, that will equal 7. So I have the coordinate negative 2, 7. And if I do negative 1 plus 1 cubed plus 8, that's going to equal 8. So I have the point negative 1, 8. And if I put 0 into my function, 0 plus 1 cubed plus 8, that's going to equal 9. So I have the point 0, 9. For 1 plus 1, quantity cubed plus 8, that's going to equal 16. So I'll have the point 1, 16. I could continue this as far as I wanted to, but we can see that my y values are getting rather large for my graph. If I plot these points, negative 3, 0, negative 2, 7, negative 1, 8, 0, 9, and 1, 16, which is off my graph up here, we can get a rough sketch of my resulting graph.